Welcome, everybody. We're going to get started here. So I want to welcome everybody to our conversation about 3D printing critically needed medical supplies with Professor Martin Culpepper. Today's event actually started with, can you hear me okay?
Call Jonathan.
Jonathan. So I asked Jonathan to mute himself. So we're working out the technology as we go here. But today's conversation actually started with a conversation that I had with some colleagues at my agency, Fire&Spark, where we were talking about how to help the service bureaus that we work with, and all of them want to help frontline workers stay safe. We're getting a lot of questions about how 3D printing service bureaus could do that. So I was introduced to Marty Culpepper, and he started telling me everything you could ever want to know about 3D printing medical supplies, PPE. And I said, hey, wait, slow down, Marty. We need to do this on a webinar where all of the service bureaus that we work with can benefit from the conversation. So we don't have a ton of Marty's time as they're trying to work out their audio as we speak. So we're going to move quickly through this with a couple quick introductions, and then we're going to jump into our conversation with Professor Marty Culpepper. So very quickly, my name is Dale Bertrand. I run Fire&Spark. We're a marketing agency focused on manufacturing space and 3D printing companies. So we've worked with Stratasys and GrabCAD and MakerBot and a bunch of others. I'm gonna let Konstantin, who's the other sponsor of today's event, say a couple words about DigiFabster quickly.
Yeah, hello everybody. My name is Konstantin. I'm a CEO and the founder of DigiFabster. So we are a software company based in California. Our technology helps hundreds of the 3D printing, CNC, or sheet metal shops to streamline the sales processes, to accept orders online, and just to simplify the whole communication between buyer and shop supplier. So.
All right, thank you, Konstantin. So now I'd like to introduce Matt Cameron. Matt Cameron is an instructor at MIT, so he teaches courses like Design for 3D Printing and Intro to Making. Mac also used to work at Stratasys, so he did a stint at Stratasys as an applications engineer before MIT, and I'm gonna hand it over to Mac and let Mac introduce our speakers for today.
All right, well, thank you very much. I appreciate it. I actually teach Intro to Making with Jonathan and Marty at MIT. It's been an amazing time. Thank you guys for joining us. Professor Marty Culpepper is one of the leaders of a special governance team at MIT formulated for the guidance of 3D printing manufacturing and the sterilization of PPE use in a medical facility. He's also the Maker Czar and leads MIT's efforts to upgrade legacy equipment, introduce new technologies, and create new maker spaces on campus. So thank you so much. Jonathan's joining us. He's also the associate director and certainly helps with a lot of the making and developing here at MIT as well. Marty, thank you again so much for joining us. How are you doing?
I'm doing all right. How are you, Mac?
Doing very good. Can you just give us an overview of some of the stuff you've been working on, and especially in the PPE space and making some of these pieces of equipment?
Sure. Let me give you an overview of what's happening at MIT and how I fit into this, and then that'll give some context for the types of things we've been involved in. When the COVID situation started here in the States, MIT stood up a COVID task force. I am one of the co-leads on the PPE manufacturing task force. So this deals with not only 3D printing, but any manner of being able to fabricate PPE that could be deployed, whether it's to EMS, firefighters, elder care facilities, public works, police, or of course hospitals. So we've been at this for several weeks now. It's been our job to look at what is needed to try to find new ways to fill the gaps in supply for PPE. But in addition to that, there's something equally important, which is how to slow down the burn rate of PPE. And both of those things are very important. They're linked. So there are gaps in supply. Those gaps will stabilize. How do we fill the gaps in the short term? but then also making sure that people have enough of it, depends on how much they're using. So there are opportunities to try to create other things, things other than PPE that mitigate the burn rate, right? So it's a combination of those two things that are currently needed. And like I said before, this isn't just hospitals. This is needed, fire, EMS, police, etc. But then also people are starting to look forward to the need that goes beyond the immediate crisis, which is, if, for example, the country starts to open in certain locations throughout the summer, PPE isn't only going to be needed for your professionals that are dealing with sick patients, but also potentially the average citizen might need these sorts of things. So there's the opportunity to be able to provide things of use to people on a much broader scale than we. So in the answer to the question of what is it that we're up to now, we have things that fit into the two buckets, filling in the supply gaps, but then also mitigating the burn rate. So in terms of filling the gaps, we've done a lot of work on face shields. And I want to try to share a repeated theme that we've noted here. A lot of do-it-yourself type folks are trying to help, well-intended, build certain things. It's very important for them to think very carefully before they start to build things. Can they build enough of these things to make a dent in the problem? So for example, there are a variety of 3D printed face shields, for example, where you have the band that's 3D printed and then you have the plastic that snaps onto that. There are very few people in the United States, and actually Stratasys is one of the companies, but there are very few people or entities in the United States that can actually fabricate these at a rate that are going to actually matter. So I believe Stratasys is capable of doing several tens of thousands of these per day. But to give you an idea of scale, for disposable face shields, individual states need millions of these every month, and they're going to need them for several months. And so although people may want to try to 3D print solutions like this, it's not always the best idea. And there's a couple reasons for that. First reason is every time somebody buys plastic up out of the supply chain, it takes away plastic from people that can create shields at hundreds of thousands to millions per day. That is actually what is required, right? So people have to think very carefully about where they're going to invest their time, because yes, you may be able to use your plastic to make 100 of these per day, but you're really taking that plastic out of the supply chain. It's jacking up the cost of the plastic, and it's making it difficult for the people that can produce at the high rates needed to be able to get access to that plastic. That's a real example that we've had an issue with. We saw the supply in plastic sheet dry up within a matter of days because everybody was buying it. So face shields are one of the things we're working on. With respect to mitigating the burn rate of PPE, typically when a nurse or a doctor goes into a room where there's a patient, they have to don PPE. So this is a gown. You're talking about maybe goggles, face shield, respirator, a mask, hair covering, etc. And then when they leave that room, they have to take it off. All right, so these things have to be disposable. This is why we're going through these at a very high rate. So if there are solutions that people can come up with that prevent the need for so many people to go into a room, if you don't have to send a team of doctors into a room, if you can get away with just sending one doctor and then provide a solution so it's easy for that doctor to share the information with the other 4 or 5 people sitting in the hallway, that saves a lot of PPE. So this is an example of the mitigation of the burn rate. For example, one of the things we're working on at MIT is a Bluetooth stethoscope. So if, for example, somebody needs to listen to understand cardiac function or to understand pulmonary function, it's possible for one person to don PPE, go into a room, place the stethoscope, and then there's a Bluetooth speaker in the hallway that the rest of the team can listen to. And then they can do this without having to don and then doff any of the PPE. So I think people need to take a broader view of the kinds of ways that they can help. It's not just creating, the PPE that you see on the news, right? Face shields, masks, these sorts of things. There's a bigger problem. There are bigger issues to be dealt with, not only for the immediate future, but also for the next 4 to 6 months after this.
Yeah, that's a great point. And just along those lines, and even just relating to where the 3D printing community can have a big impact. This is a question from Braden, was a co-founder of Robo3D. of what types of products, if any, do you see opportunities for within the 3D printing community to create legitimate reusables that can be helpful across an industry?
Sure. So the FDA has classified devices with various numbers. So for example, a face shield, it's class 1 device. You start getting into class 2 and class 3 devices, you're talking about, people are very leery of new things in those classes that get introduced into a hospital setting. All right. I can honestly tell you with the class 1 device face shield that we have, there's still a bit of a barrier in some of the hospitals of getting them in. It's a very conservative supply chain, very conservative people in procurement, and they're not necessarily thinking, you know, in terms of the crisis at hand. They are stuck, for lack of a better word, in pre-pandemic thought mode, right? So I would stay away from things that aren't class 1 or below that. All right. I would also stay away from products that require sanitization. So for example, face shields. One of the reasons why we tried, at MIT, we actually have a ban on 3D printing things for PPE unless they get special permission. And part of the reason for this is, you know, with the best of intentions and try as hard as you might, you can print parts for 3D print parts for a face shield, send them into a facility, but the doctors and the nurses could be so desperate and they're so fearful in not having what they need that they may try to reuse it if it was intended to be disposable. And these things are not necessarily the easiest to sanitize. You know, typical methods right now involve using wipes, special wipes hospitals use. And, you know, there's no guarantee right now that the wipes and the chemicals are able to get down into all the little crevices where virus particles could hide. And then plus 3D printed parts, depending upon how they're made, they can be porous. Okay. So people, you know, it's these sorts of things that people need to take into account. You know, and we hear a lot about people say, well, we can 3D print in this material and then you can sterilize it in this other way. You know, but you can't retrain hospital staff. They can't have multiple sanitization techniques. You can't retrain them, etc. So with all that said, you know, the sweet spot for these sorts of things are any kind of application where it doesn't need to go through FDA approval, where it provides a reasonable benefit, where there's a very low barrier of getting it into the hospital, and then where you don't have to worry about things such as sanitization and or introduce any new kinds of techniques. The hospitals are so busy right now, they just do not have the bandwidth to try to bring on new techniques or to try to manage new, you know, hazardous waste flow, these sorts of things. So I'll give you a good example. You know, masks right now, you know, there's a lot of talk on the news about the fact that masks are in short supply. And when we first got started, what we found is some of the hospitals in the local area, you know, they had a lot of masks, but it was just in certain sizes that they didn't have them. What are these things called? I think they're ear protectors or something like this. They look like a comb. They fit behind the back of the head. And instead of running the straps for the mask around the ears, you can run them through these protectors. So you can actually use it in some cases, not all cases, but you may be able to use a different size mask or a mask with a different elastic with this intermediary part that the mask hooks to. Again, something that doesn't have to be sanitized, something that's not a class 1 device or higher. You know, things like that could be extremely useful.
So what are some of the broader implications for this in society? And are there other ways that service bureaus and manufacturers can get involved?
Yeah, I think the best thing for people to do, and we learned this the hard way, when this whole thing hit, MIT, you know, we took off like a rocket ship and we found ourselves so far ahead of both governments and, you know, both, you know, the classes of governments and then also the classes of hospitals, that they didn't know what to do with us. We were making, for example, you know, tens of thousands of face shields per day, and people were shocked to find out suddenly there was a new supply. What I would highly recommend is that people find some way to get in contact with the COVID task forces in their state and get an assessment of what is really needed. All right. So for example, we learned that it was, you know, they had a number of 1.4 million face shields per month was what was needed for Massachusetts. You know, but there are also things like gowns. There are a variety of different things that people need. And what you do not want to end up doing is, you know, make 1,000 or 2,000 of something and then they sit in a box and nobody ever uses them because they're not really needed. Okay. So step number 1 is for the service bureaus is just find who to contact, you know, either at, you know, the city government level, because they have needs for their EMS, firefighters, police, public works people, or the state government. Very difficult to talk to hospitals right now, but you could try. But identify the need and then identify the quantity, right? So if you can 3D print, a visor for a face shield and it takes you an hour or two, it's never going to be practical, right? But if you could, 3D print a multiplicity of these ear saver things, let's say you can get 10 of these done in a half an hour or something like that, that may make a dent in the problem that people are having. So that identifying the need is critical. Second thing I want to share with people is that there are two kinds of PPE floating around right now, and it's making almost all kinds of PPE useless to people. The first kind is PPE that looks like it's supposed to work. Second kind of PPE that actually works right. So for example, you see a lot of face shields on the internet where parts have been 3D printed and the face shields wrap around the front, but they don't actually have any protection here. They don't have side protection. They don't have protection underneath. That's what people are really looking for, right? And in the absence of having like a physician on a team, people tend to end up designing things that look like what they think they should look like. But I can guarantee you that there are a lot of places right now where people donate these sorts of things and they're just being thrown away because people, they don't have the input from the clinical side to make sure that things work right. So if there's a way for people to partner up with somebody that has some knowledge about these sorts of things, that's important. And then also the ability to find a way to get your design tested out by clinical people. Nobody's going to let any of these things come into a hospital unless somebody that uses them has actually tried them. And you may be able to start, for example, with the local EMS, get feedback from them, and then maybe they can get you a contact in one of the local urgent care clinics. And you can work your way up the chain like that. And if you're lucky to get to the hospital level where people are interested in looking at your design, just keep in mind they generally have to do an internal review board where they'll want a variety of prototypes. They'll have an assessment. Usually this can be done in 1 or 2 days, an assessment period. And if all goes well, then that paves the way for you to get the things that you're building into the hospital. It's a very, I don't mean to sound.
Yeah, no, that's super helpful. And I think it's important to build those relationships as well. I have one more question before I get to more audience questions. Is just what future opportunities might there be out there, especially as we start going, back to movie theaters, back to restaurants, back to sporting events. What do you envision happening within the PPE need?
Unless you have, so I think for 3D printing in particular, I think unless you have a very special kind of 3D printing where you can guarantee that parts aren't going to be porous and this sort of thing, what you're going to be able to do is somewhat limited. All right. The last thing you want to do is give somebody a false sense of security and then they end up getting sick, right? That's just, it'd be better for them to have nothing, to be honest with you. And I don't mean to sound all doom and gloom here. I'm just being very practical and straightforward with people. With the hope that they'll be very critical in their thinking in terms of where they focus their efforts. As time moves along, I foresee that people are going to need the ability to store things. For example, if you go out, for example, right now a lot of people are putting their phones in Ziploc bags, but what ends up happening is people don't realize right now when they end up taking their phone out of the bag, they can contaminate their hands and they touch the bag, etc. I think there's going to be a need for systems where people can manage what they have that's known to be clean versus things that may not be clean. Awesome. All right. So these could be like your keys, wallet, cell phone, maybe containers that are color coded according to whatever they're printed out of, where people can, for example, in your car, keep things, every time I go to the store and I come back, my credit card is contaminated, right? And where do I put it? So I need to have some place to sit that where I know it's a dirty box, and then some place to keep everything else that I haven't touched with dirty hands that's a clean box.
Yeah, that's a great point. All right, I'm going to spend the last 10 minutes just going over the questions that have been asked by the participants here, and if we could just keep quick answers to these, and then we'll follow up afterwards. So from your experience, have you seen governments or hospitals providing any funding to offset the cost of these materials? Or are these a lot of times just relied on donations?
I've seen everything. So I've seen some hospitals willing to pay, lots of donations being taken in. FEMA and statewide equivalents are paying for these things, so it could be anything.
Mm-hmm. So one of the great projects that have come out of MIT so far is the flat face shield that you've been working on.
Mm-hmm.
Are those reusable? And are those shields good if they can be cleaned? If so, are they being sanitized and re-cleaned?
We designed them so that they were disposable. There are a variety of different needs for face shields, different kinds of face shields in a hospital setting. They were designed to be disposable and not reused, but we do know people have been wiping them down and reusing them, but we don't recommend it.
There's another question about just different types of N95 masks. Besides the 3M N95 mask, are there others that you've seen that are good and can stop the virus?
So there are different ratings for masks like this, NIOSH ratings, etc. We've seen N95s, KN95s, a variety of others that are supposed to do the job. But part of the problem right now is there's a lot of counterfeits. And so we've got loads and loads of good masks that are sitting unused because people don't have a good way to tell the good from the bad, right? But there are other options, okay? One of the things I would like to caution people against, every doctor I've talked to about 3D printed masks, so first off, it's not the mask that's the problem, it's the filter media. It's a very specific kind of media. It's highly engineered microstructure with electrically charged fibers that actually do the filtering. The media is the problem, all right? It's not the masks. And then when in a clinical setting, when someone is using a mask, there's a very stringent fitting criteria they go through. So you see, for example, people talking about putting 3D printed parts in hot water and trying to form it to your face. It's a highly dangerous thing for people to be doing. I would really recommend that people not, unless you have a lot of engineering and material science and clinical knowledge and 3D printing technologies that are fairly advanced, not to be working on printing the bodies of the masks.
Any advice for helping larger companies donate materials, even with this shortage?
Yeah. One of the things that MIT did when we moved everybody off campus is we have a lot of PPE that people use in labs and shops and maker spaces, and we just donated it all. If in a larger company, because people have been moved out or put on furlough or whatever, people, the best way you can help is to find that PPE that's in unopened packages, it's professional, it's already registered, it's already been approved, and find a way to donate that to the hospitals. I wouldn't go to the hospitals themselves. It's not the best place to be right now. Find a local entity that is handling donations, try to donate through them, or try to get it to a local government and they can take care of it.
So what about the kind of 3D printed accessories to these masks? For example, the clips that would go on the back of the head to save the ears. Mm-hmm. How are those any safer? Those should also still be used with caution.
I think in my mind's eye, all right, those are not something that in general are forward facing to a patient where they're often going to be exposed, all right. I think they're in line with the types of products that you can provide to the hospital, and they can make their own decision about whether or not they want to use them, right? And all these things are going to make their own decision, but they should be able to make their own decisions about those. I would really avoid anything that's supposed to be protective in nature, because if it's supposed to be protective, it will be exposed, and this is where you start running into problems.
Okay. What about just sanitizing in general? Do you have thoughts on what sanitization methods are working, and sanitizing stuff that is meant for reuse?
So some people use 10% bleach solution, and then there are these wipes. Mac, I could send you the link to these things. There's like 3 or 4 different kinds of wipes that they use in hospitals to do sanitization. But in general, I think it's either alcohol-based or bleach-based kinds of wipes. And it's very difficult for a healthcare professional to know what material they have in their hand and whether or not it's compatible with bleach. And then even if it is, supposed to be compatible, there's no guarantee, there's no research right now on whether or not these things can actually get down into crevices or soak into 3D printed parts to kill the virus. In all the things that are going on right now in the time frames we're looking at, nobody's going to figure that out, right? It's just, if people are worrying, if people are thinking they'll be able to prove that sanitization is going to work, and so they'll start making things that can be sanitized, unless you have a lot of expertise in that and specific materials and you can guarantee there's no porosity, etc., it's just not going to be practical to build things like that in any time to make a dent.
Okay. And then the final question, and Jonathan, I'd love, even for you to chime in, with any of your thoughts as well. Adding approved filter materials to maybe the exterior of, maybe 3D printed or other technologies, does that help make those 3D printed parts safer if they're covered by something, or would you recommend staying away from that as well?
Not quite sure what you mean. Do you mean like putting filter media over top of a 3D printed mask type thing?
Yeah, I guess the exact question would be, what if you have technology that allows for the filtration or purification that attaches to existing PPE, like helmets? How would you foresee that?
So if it has to do with filtration, I would stay away from it. All right. The doctors, the nurses, the aides, they're all very particular about these respirators. I mean, those are the kinds of things where they absolutely have to function correctly. And if you take any risks with those, it only takes a few healthcare workers to get sick to infect all the other workers in the same facility. That's something people do not want to monkey around with. But other products, if there's a way of protecting them, if for example you need a structure that could be 3D printed and then you can cover it with something else to prevent it from getting contaminated, I think there may be potential there. But before you embark on something like that, you definitely want to talk with somebody, for example, in EMS or urgent care center, hospital, to see what they think.
And the volume as well. Jonathan, do you have anything to add, or just thoughts to share as we close this up? Oh, you're on mute.
Can't hear you, bud. No, it looks like we're not going to get him.
Okay.
So while he's trying to figure it out, can I make another comment here?
Of course.
In all the way we're looking at this at MIT is any minute that we spend, if we don't spend it properly, that impacts lives saved. The key thing, I don't mean to sound like a naysayer, right? 3D printing can have a part in this, but it's been hyped up too much in the government and the news as a cure-all. It really depends on what kind of 3D printing you can do, how well you have control, what materials you have at your disposal, and whether or not what you will make the clinical people will accept, right? Those are the key things. You got to have all your ducks in a row on those things.
Awesome. So if people want to stay connected or just continue to hear what's going on at MIT and some of the stuff you're doing, if they can help, or they want to learn more, where can they go for that?
So the best thing to do right now is contact somebody local to you and find out what they need. That's the first place to start, right? I can tell you at MIT, we're inundated with external requests, and so it's difficult for us to respond to everybody that's writing to us. But I think people, if they have some engineering skill, the ability to integrate some clinical on top of that, and the ability to get connected with people that know what's needed, they don't need us, right? They can start off, they can embark on that process on their own.
Outstanding. Well, thank you so much, Marty, for your time. It's greatly appreciated. This was a very short 30-minute session with a lot of information. I hope it was helpful to all of the people who've attended. And Dale, if you want to maybe close with closing remarks. And again, we really appreciate you guys being here. And looks like you're muted as well, Dale.
All right, so I want to thank you guys, Marty and Jonathan, for being on. I know you guys have a number of critical needs that you're fulfilling right now. So you've got a meeting after this with another group that urgently needs your time.
Yes,
So I really, really appreciate the fact that you guys were able to take 30 minutes with us here today. And we'll let you go while Mac and I wrap up with the audience.
All right.
But thank you.
No, thank you so much. Thank you, guys.
Because it's a virtual event. So just wanted to make sure everybody who's still on, I learned a ton. We are going to be writing up our own notes and communicating them. One way that Fire&Spark, with our partnership with DigiFapster, that we could all help is by us reaching out to the task force in the different cities and states. And that's something that my team has been working on, and we'll distribute, just like we're distributing the information that we're getting on this webinar, we'll distribute that to anybody who's interested in understanding exactly what the different task force need. So Constantine and I will be working on that to make sure everybody has a perfect understanding of what's actually needed in your area. So definitely reach out to us. I have another slide I can show. So here's my contact information, but send me an email if you're interested in that or anything else that we're doing. I do want to point out, like right now, we're dealing with a critical shortage of medical supplies. So in the short term, we're expecting that to be really the focus. But moving into the midterm, let's say, for a month, 2 or 3 out, we're going to be looking at opening up parts of the country, and we're going to have corporate buyers out there, maybe manufacturing facilities, maybe corporations with desk workers, who are all going to be interested in their own types of PPE. And that's one of the opportunities that we're looking at and trying to make sure that we are prepared for. And then the longer term opportunity for our community is really going to be how to ramp up supplying governments and hospitals while they're backfilling their stockpiles, which is really a long way out from where we are now. But those are the 3 areas that we're looking at, trying to make sure that we are prepared. So thank you everybody for coming on and participating. Definitely reach out, let us know how we can be helpful to the community going forward, and we will see you next time.
Thank you so much.
All right, bye-bye.
Yep, thanks.